All right, so this is 3.6a. We'll actually finish up with 3.6b tomorrow. For your warm-up for 3.6a, which is today, we're going to find the slope between 2 points. So your formula is at the top, up here at the top right here. And go ahead and pause the video and then come back when you're finished. All right, so if you recall, the first thing I'm supposed to do is I see a bunch of y1s, y2, y1, x2, x1. So first I'm going to go through and do is label my points. So this is going to be x1, this is y1, this is x2, this is y2. So my slope is going to be y2. So as I plug in y2 first, so negative 2, minus y1, which is 6, all over x2, which is 15, minus x1, which is 5. So that's going to give me a slope of negative 8 over 10, which reduces to negative 4 over 5. All right, so for this one, I'm going to still use the slope formula, but I'm going to do it a little bit differently because my personal preference is not to write all the x1s and the y1s and so on and so forth. I'm still basically going to do the same thing, except I'm going to use arrows to find my y1s and y2s and so on and so forth. So here we go. I'm going to take my y2 minus my y1, which is 3 minus 0, which is going to give me 3, divided by my x2 minus my x1. So that is going to give me negative 4 minus negative 4, which is going to give me, oops, let's fix this over here. So on the top I've got 3, on the bottom I've got 0. So before you start telling me that that has a slope of 0, I want to show you a little video clip that will probably help you understand more about slopes. So give me a second to get that loaded up here.
Adventurous Slope Dude. Meet Slope Dude. He loves to ski. We are going to follow him, and he'll teach us some important aspects of slope. This is the course he's skiing today. What he says will teach us about slope. Always remember that Slope Dude always skis toward the right or eastward. When he starts out, he's going uphill. It's hard work. He says, puff, puff, positive, as he goes up the mountainside. Puff, puff, positive, puff, puff, positive. Now he's at the top. It was puff, puff, positive all the way up the mountain, but now he can look forward to the downhill. On the way down the mountain, he says, nice, negative, nice, negative, nice, negative. And now, after the downhill, he's in for the hardest part of the ski route, the long, flat part. He says, this is zero fun. This is zero fun. This is zero fun. As he finishes the flat part, he doesn't see well ahead, and all of a sudden he comes to the edge of a cliff. It's straight down. He finds a slope that is straight down and so frightening, faces the worst curse word possible in math and in algebra. Undefined. This has been the adventure of Slope Dude. Remember always what he said during his ski trip. Up the hill or up the slope, he said, puff, puff, positive. On his downhill run, he said, nice, negative. On the long flat part of the course, he said, this is zero fun. And finally, when he went over the vertical cliff and straight down, he yelled the worst curse word of math and algebra. Undefined. The uphill is a slope with a positive number, the downhill is a slope with a negative number. The flat part is a slope of 0, and the straight up and down, or vertical part, is undefined.
Okay, sorry about that. I know there was a couple interruptions in there with the bell and the emails and stuff, but let's just finish this up. So we talked about the puff, puff, positive, the Slope Dude. And the nice negative, so puff, puff, positive, nice negative, horizontal line is zero fun. So it has a zero slope, and then we have the undefined, which is a vertical line. So I want to go ahead and I want to plot these points here. This -4, 0, I'm just going to make myself a little rough sketch. So let's see what we got here. So I'm going to write over here, my slope was 3/0. Okay. All right, so I'm going to make myself a little rough sketch of these points. So I've got -4, 0, that's right here. And then I've got -4, +3. So -4, +3 is going to be right here. So there we go, we got a vertical line. So because my slope has a 0 on the bottom and I cannot divide by 0, if you try to put that in your calculator, you will get an error. Okay, looking at my points, I've got a vertical slope, which means I have undefined. So whenever you have a 0 in the denominator, you are going to have a vertical line with an undefined slope. All right, there's your table of contents and your objective. All right, definition of slope. Slope tells me steepness of a line. So it tells me how steep. It also tells me direction. So is it puff, puff, positive? Is it nice, negative? Is it 0 fun? Or is it undefined? Okay, the slope formula. If I'm looking at a graph, I can count the slope by using rise over run. If I'm given 2 points, kind of like what we did in the bell work, I'm going to use my slope formula, which is y2 minus y1 all over x2 minus x1. Okay, parallel lines, we've talked about this previously in the unit. Parallel lines have equal slopes. So for example, I'm going to write an equation of a line in slope-intercept form, so y equals 2x minus 1. A line that is parallel to that would have to have the same slope, so it would be y equals 2x, and then, I don't know, it just has to have a different y-intercept, so I'll put 4. So since they have the same slope, they are parallel. Perpendicular lines have negative reciprocals. All right. So a negative reciprocal, here's an example of a negative reciprocal. If I have a fraction that is 3/4, the negative reciprocal would be I flip the fraction upside down and make it negative. So example of 2 lines that are perpendicular would be y equals, let's make something up, 4/3 x plus 1. The perpendicular line would have a negative reciprocal slope, so -3/4x. And then it could have the same y-intercept, or it might have a different one. Just as long as the slopes are negative reciprocal, that's all we're really concerned about with that. All right, compare the 2 lines in each example below. In example number 1, are the lines parallel, perpendicular, or neither? Well, since they have the same slope, we are going to call them parallel. All right, example number 2. Parallel, perpendicular, or neither. So let's take a look at the slopes here. We've got 2/3 and -3/2. So the slopes, the fraction has definitely been flipped, and it is negative, so they are perpendicular. I'm just going to write the little symbol that we learned yesterday, perpendicular. I could have written the parallel symbol up here also. All right, bottom one, 2x plus 3 and 1/2 x plus 1. Those would be neither, because while 1/2 is the reciprocal of 2, let's put a 1 under that. While 1/2 is the reciprocal of 2, it is not negative 1/2. So without the negative, they are not perpendicular, and they are certainly not parallel, so I'm going to say they are neither. All right, are the following two lines parallel, perpendicular, or neither? Okay, well, the slope of this guy is 1/3. I can't tell the slope of the second equation here because it's not in slope-intercept form, so I'm going to have to go ahead and solve for y. And then I'll be able to tell if the slopes are equal to each other or inverse reciprocals. All right, so the first thing I got to do is divide everything by 6. That is going to give me y equals 2/6x, which actually reduces to 1/3, plus 2. 12 divided by 6 is 2. Now, since my slopes are equal, I can say that my lines are parallel. All right, take a minute, copy these down, and then come back and tell me if they're parallel, perpendicular, or neither. All right, so I've gone ahead and worked the problem for you, and the slope of my first line is 2, but keep in mind I can put a 1 under that, okay, make it a fraction. So my first one is 2/1. My second line has a slope of 1/2, and it is the opposite of that, so these lines are perpendicular. All right, given the following points, are AB and CD parallel, perpendicular, or neither? So go ahead, you've got the slope formula here, so you're going to find the slope first of line segment AB, then you're going to find the slope of line segment CD, and tell me if they are parallel, perpendicular, or neither. All right, using the slope formula, you should have got the slope of AB is 4/5, and the slope of CD is also 4/5, which makes the two lines parallel. All right, on your own, try that exercise and tell me if they're parallel, perpendicular, or neither. Just realize that these are the same numbers, so I'm going to go ahead and change them up a little for you. Put some negatives in front of there, and then see if they are parallel, perpendicular, or neither. All right, so you should have gotten that those are neither. The slope of AB is -4/5, and the slope of CD is +4/7. Calculate the slope of the line that passes through the labeled points. All right, so here's where, if you really like using the slope formula, which I personally do not, but if you really like using the slope formula, you may, but I like to count, because I know that the slope is equal to the rise over the run. So the rise is my vertical change, and the run is my horizontal change. So starting from either point, it doesn't matter. I have to travel first vertically, then horizontally to get to the other point. So I'm going to start here and go up 1, 2, 3, 4, 5, 6. So I have a vertical change of 6, and then I have a horizontal change of -2, so my slope is 6/-2, which is -3. All right, I want to point out that you could have gone the other way, so I could have started at this point, and I could have gone down 1, 2, 3, 4, 5, 6, which is a vertical change of -6. And a horizontal change of 2, so that would give me -6/+2, which is still a slope of -3. So no matter which way you go, you're still going to get a slope of -3. Okay, so the slope of a line parallel to this line would have to have the same slope, so it would be -3. The slope of a line perpendicular to this line would be the negative reciprocal. So I'm going to turn this into a fraction. So I have to first flip the numbers, that gives me 1/3, and I have to take the opposite, the negative of it. Well, this one is already negative. This is already a negative slope, so I'm going to take the negative of a negative, so that's going to give me a positive 1/3. So positive 1/3 slope. All right, go ahead and take a minute and find the slope with a line, and line parallel and a line perpendicular. All right, so the slope of this guy is up 2 over 5. So a parallel line would have the same slope. A perpendicular line would have a negative reciprocal slope. Okay, go ahead and find the slope of each line and determine if they are parallel to each other, which means they would have the same slope. Okay, so this one has a slope of 1, 2, 3, 4, up 4, left 2, so negative 2, so 4 over negative 2 gives me a slope of negative 2. This guy here has a slope of up 1, 2, 3, left 2, slope of positive 3 over negative 2. Clearly the slopes are not equal to each other, so they are not parallel. All right, same exercise, see if the lines are parallel. All right, here we go. Up 1, 2, 3, 4 over 1. Next line, up 1, 2, 3, 4 over 1. These lines are parallel. Similar exercise, see if they're perpendicular, except now you're going to see if the slopes are negative inverses of each other or negative reciprocals of each other. So go ahead and find the slope of each line. This line, this first line, I'm going to go up 2, left 1, so positive 2, negative 1. And the second line is I'm going to go up 1 over 2. So they are indeed negative inverses of each other. They have been flipped. And one of them has a negative. So they are perpendicular, yes. All right, last example. Slope of the first line, line DC, is 1, 2, 3, 4 over 2. So I have a slope of 2. So if everything goes correctly, and these are in fact perpendicular, the slope of my next line should be negative 1/2. It should be the negative reciprocal of this. All right, so let's see where I go. I got a slope of up 1 over 1, 2, 3, 4. So didn't get what I needed out of that. I'm sorry, that should be a negative 4. Still didn't get what I needed out of that, so those are not perpendicular. All right, go ahead and get to the website and find your homework assignment for tomorrow, and you are only required to do the odd numbered problems, not the whole sheet. Have a nice day. See you tomorrow.